Hey everyone, and welcome back to our third lesson in our light show Arduino series here on my YouTube channel. And I wanted to again continue with this same board setup. You probably took a little while to put it together and don't want to take it apart quite yet. Well, we're going to keep working with it and build off of this structure to learn a little bit more about how the coding of the Arduino works. That's really what I want to emphasize. But before I go any further than that, I want to just take a second to look at this. This is a resistor in real life. We're going to be sending 5 volts out. And what the voltage is a push on the electrons that are connected in this system. There is a wire running horizontally in our breadboard, and that wire is connecting the end of this green wire to the anode of this LED. And there's another wire running here connecting the cathode to this resistor. So this voltage is pushing on these electrons, and they're making a cycle. So voltage, or potential difference, is simply the difference in the potential to do this electrical work that's coming out at the top of the circuit and finishing down at the bottom. And all those 5 volts must be used up. That's how the difference is created. In the same way that if I drop something from a very high height, that's the potential energy, is that height that it's at. Well, all that potential energy is going to be used up by the time that object hits the ground, whether I slow it down or not. And so we're going to slow this down, so to speak. What we're technically going to be doing is using up some of this voltage. We're going to cause this voltage to drop by having this resistor convert the electrical energy into heat. So we're going to be doing some converting of this work being done by this electrical circuit into heat. And that's what a resistor does. It resists the flow of electricity. And that's really important, because if we don't have that, these LEDs, they can't handle the full 5 voltage, and they could end up breaking. All right, so just wanted to take a quick second to talk about that. All right, I'm going to start with a blank slate once again, because I am going to be adding in a button. Oh, you know what? We're not ready for the code then. Let's start with the button. So I'm going to take one of these push buttons. And a push button has little grabby feet, and they kind of grab over this channel. Now, you'll notice that these channels, they block this wire. See, this wire coming out here is not the same as this over here. You'll notice this is called 1A and this is 1B. Well, 1A, terminal 1 is connected. So right now I've actually connected this side to this side. But what's not connected is terminal 2 and terminal 1. When you press this button, what happens is a metal plate pushes down and connects terminal 2 to terminal 1. Well, what we're going to do is we're going to go ahead and install a button so that we can use it. So here's how we do that. We're going to connect from the 5 volts connected to our Arduino, and I'm going to color that red so we can see that's positive. That's the 5 volts. And then when that button gets pressed, we're going to send that 5 volts into pin 2. Okay, and I'm just going to label that one orange just to make it stand out, that I'm inputting in this voltage. So in this way, when the button is pressed, 5 volts will be going into pin 2. But there's a problem here. See, voltage is really a comparison. And so for me to have the Arduino detect 5 volts would be like me asking you to tell me, how bright is it? Well, I mean, okay, but that depends, I mean, is it bright if you're in a dark room and I turn on a little flashlight? Well, that's bright. Well, if I'm in a bright sunny day and I try to read my cell phone, then the cell phone, I can't read it, right? Because brightness, just like color, just like height, all those things are comparisons. We have to have something to compare something to. And right now, when I have this Arduino hooked up, yeah, I can send it 5 volts, but how will it know the 5 volts that it's getting is 5 volts more than what? We have to let it compare to something else. So what we do is we connect this to ground. And you may think that we would do that with a wire. So let me show that. So now I've got my pin 2, which will be reading the button input. I've got it connected to, oh, actually that's the wrong thing. Okay, so I've got it connected to ground here. So now it can compare. It can see, okay, I know what ground is. When I press the button, I'll see what 5 volts is. But the problem there is when the button's pressed, it will go through this black wire. And it won't go into our pin on the Arduino. So this is a problem as well. So we need to kind of be clever about how we do this. And the way we're going to do is we're going to use another resistor. So I'm going to pull off one of these guys here and connect it. Oh, I'll need to change this wire then. Put it there. All right, well, this is currently a 1 kilo ohm resistor. We'll make it 10 kilo ohms. The colors are brown for 1, black for 0, and orange is 3. And this third color tells you how many zeros to add. So 1, 0, add 3 zeros. This is 10,000 ohms. So when the button is not pressed, we're connected to ground through a 10K resistor. But when the button is pressed, the volts, the electricity flowing through this wire, the electrons will have a choice. They can either take the orange wire of no resistance, or they can take the resistor to ground of 10,000 resistance. Well, resistance is how much you resist the flow of the electrons. Well, electricity, we all know, likes to take the path of least resistance. So the electricity will flow here instead. So when the button's not pressed, we're connected to ground. We know what ground is. When the button is pressed, we can get the full 5 volts. This resistor here is called a pull-down resistor. They're used all the time when setting up digital inputs and buttons. And so we always use a 10K resistor. It's just kind of a way to comment to people looking at our circuit what kind of resistor it is. What is its purpose? These resistors here, their purpose is to keep these LEDs from getting too much electricity and breaking, busting open. This resistor here, 10K resistor, oh, it's just a pull-down resistor. It's just to pull this buttons down the ground so that it's not floating in between. All right, now we're ready to get going on the code. We're going to introduce some good coding concepts. I'm not going to use constants for everything yet, but I am going to start using them. And as we go further, I'll use more and more. So I'm going to create a new variable, okay? The variable is going to be the pin number for this button. The pin number is pin 2. 2 is an integer. And I'm going to put it right there. This tells the Arduino that I'm going to be making a variable name, and it will be of type of an integer, so it will be holding whole number types and their negatives. This is the name of the variable, and this is me assigning it the value of 2. I'm going to go one step further. I'm going to put const, which makes it a constant, meaning that I cannot change it. So if I try and do something, say like this, or this, it's going to cause me an error, and I want that. I want to know that I've accidentally tried to change a constant. Ideally, we want to list all of our constants at the top of our Arduino program so that people can see where things are lined up on our board. And so if someone else plugs their button into a different pin, all they have to do is change this number. They don't have to change it everywhere in the code. All right, now we should ideally do that for all the LEDs, but we'll wait and do that at another time. So there's our setup function. And we've been through this before, but I'm going to use a for loop to initialize all these pins here that are connected to LEDs as output. To use any of these digital pins on the Arduino, we have to tell them whether they are input or output. So I'm going to first create a variable. We have to create, we have to check, we have to change. I want to start at 3. I'm going to check the variable, meaning I want you to do this code over and over again as long as x is less than or equal to 13. And I want to change the variable. I want x to go up each time after you run the loop of code. And there we have it. I have set each one of these just as if I typed in pin mode 3 output, pin mode 4 output, pin mode 5 output, pin mode 6 output. I have changed each one of these pins to be set in output. But my button, I need that to be set as input. So I'm going to make button. Now I could say pin 2, I need that to be an input. Right? Pin 2 is going to be receiving signal from the user, inputting to the system. These other pins are turning on these lights. But you know what? We made a constant. The number 2 is button pin. So instead of putting 2, I can put button pin, and that means 2. That way, if someone else plugged their button pin into, say, pin 5 or 10 or something like that, as long as they change the number here, they don't have to go down and find it in my code. It will automatically be put the right value there. All right, let's do our loop method. Well, what I want to do in my loop method is I want to run my code when the button is being pressed. So I'm going to ask a question. If digital read button pin equals high, then I want to do my code. And this is a comment here. These 2 slashes tell the Arduino, please ignore this. This is just for people looking at my code. Well, I'm going to come back to that because I got a lot to break down here in this if statement. So this says if digital read button pin equals high. Well, what does all that mean? Okay, first of all, this is an if statement. And we need to understand how to use an if statement first. So when you ask code, if I say if true, then it will do that. Maybe I want to turn on pin 8. If true. Well, true is a true statement, right? So pin 8 would be written high. Here's another way I could do that. You know what, let's go ahead and run that and make sure we see how that works. Pin 8, turn on high. Well, what about another statement? Well, is this a true statement? What if we put 5 less than 10? Is 5 less than 10? Well, you betcha. Since 5 is less than 10, this evaluates to true, and this code gets executed. All right, well, what if I said if 10 is less than 5? Nothing happens. It's looping. It's continuously calling this loop function, and it continuously asks, is 10 less than 5? And the answer is no, it's not. In other words, false. And because it's false, it doesn't do the code inside there. So if I say if false, that's what it's doing, okay? All right, so back to what we had before. if digital read. What is that? We've seen digital write. Now I have digital read. Digital read is available to us only on pins that are input. You write output, but you read input. So we're going to digital read, and it takes, this function takes one parameter or argument, the pin number. We're going to be reading pin 2, right? But we're going to follow good coding habits. Let's not call it pin 2. Let's call it button pin. But this is really saying digital read 2, pin 2. Now this value can be either high or low. So we're trying to see, does it equal high? Well, you might think I would say something like that. But remember, the equal sign is for assignment, like when I assign 2 to button pin or 3 to X. So this symbol for it being equals is already used up. We don't have a symbol for equals anymore because we've already used it for assigning. So we have to use 2 equal signs. So 2 equal signs is asking, are you equal? Is this equal to that? Is it reading high? If it's not being pressed, it's reading low, capital L-O-W. It's another special constant. So if that's happening, then we're going to do something. We're going to say for int x equals 3, x less than or equal to 13, x plus plus. We're going to digital write pin x, which will go from 3 to 13, changing by 1 to high. Okay, running the simulation. Nothing's happening. That's because right now it's continuously going around this loop and it's reading this pin right here. And it's getting low because that's what it's connected to. Ground. Low, 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 low. I press that. And now they all turn on. But we don't ever turn them off. All right, so we'll stop the simulation there. Let's make it a light show like we had before. Let's add a delay, and then let's write it down to low. Okay, start the simulation. As long as I'm holding that button down, it's working. If I let go, it'll finish it off, and then it's done. I can press it again, and it does the light show again. So have fun making this in real life. And until next time, signing off.